Today we will talk about the CAP theorem. Hi guys, my name is Manish and today we will discuss what is CAP theorem is. So let's begin with it. So let's understand its name first. CAP. It has three letters C and A and P. So these each letter stands for a particular word. C is for consistency, A is for availability, and P is for partition tolerance. So now we know the full form of CAP: consistency, availability, and partition tolerance. Now, what are these things are like? What is consistency? What is availability? What is partition tolerance? So let's talk about each of them one by one. So we will begin with the third one here, which is partition tolerance. I have a distributed system diagram here where like this is a banking system and it has like servers allocated like across the globe. Like one is in East Asia, South Africa, South America, North America, Europe. So this is kind of like servers distributed across the globe. So I just have it here so that we can keep using during like discussion. So I'm just taking a copy of it and pasting it out and then bringing it for partition tolerance discussion. So what is partition is? Partition is due to certain network outage, some part of the system stop talking to other part. For example, if North America, South America systems stop talking to these three Europe, East Asia, and South Africa systems. While these systems can talk to each other, they can talk to each other, but they both cannot, like these two parts cannot talk to each other. So we call it partition. And the tolerance is that our system should be tolerable to handle this partition. So means that user here who is like looking for the data can still have the system running. That is called the partition tolerance. So as you can see, this is basically happening due to network outage. And network outage is the real world. That's what happens. We cannot avoid it. It's not something what we can plan. It can happen daily, it can happen monthly, it can happen yearly. And if seriously in today's world, if our system is not tolerate for partition, it will keep turning down frequently because as and when the network outage will happen, when the network will drop, your system will be down. So basically, this is something the partition tolerance, which I think is no more an optional thing. We need to have our system partition tolerated. So that was about the partition tolerance. Now let's talk about the second thing, that is C, consistency. So let's say we have these two users here. One is here, another is at this location. This is user 1 and this is user 2. So now when this user 1 trying to see the data in a particular bank account, how much balance it is, it's taking that information from, let's say, Europe server. So user 2 is reading the information from North America server, and both of them see the same information. So he is also looking that yes, account ABC has X dollar, and this is also looking and getting the same information, account ABC has X dollar. So information is consistent here, which means that this is both systems around the across the globe giving the same data. That's called the consistency of the information. So basically data should be consistent. That's what the consistency means. But now think a scenario where let's say a network outage happens here. So due to the network outage, South Africa and North Africa servers cannot talk to rest of the servers. And now in this account of user 1, let's say a transaction comes which is like to have a salary deposit. Dollar Y. So the transaction goes here, salary dollar Y, and that get reflected into server of Europe, East Asia, South Africa. So all these servers get that information, but due to network outage and there is a partition right now, this information never reached to North America or South America server. Now at this location, when user watch into the account detail for this ABC account, it see that account balance is still $X, while at this location the amount is $X plus $Y now, which means the information is not consistent here. And this is what we call the weak consistency. Now there is like another consistency that is called strong consistency. Now think the scenario when the post transaction for salary came to the Europe server, it go to East Asia, South Africa, but when it try to reach to North America and South America servers, it gives error. And what it does, it does not perform this transaction on any of the server, not on Europe, East Asia, South Africa, and what it returns back to the user, that salary cannot be deposited. So it means the balance still retain $X. So in this case, if you will see, the user 2 and user 1 both will see the same data $X. That is called the strong consistency. Strong consistency means that a transaction or a change in the data will get succeeded only if that will get propagated to all the servers, which means that at any moment all server will have the same data and data is consistent across the globe. Now the third thing comes here is that is most interesting, and most of the in system design we choose this, and that is called eventual consistency. We have 5 servers here in this example, and we define that we will say a transaction successful only if post request will get success response from 3 servers, minimum 3 servers. So now what happened? Now the user 1, here a post transaction comes for $Y and it gets success on Europe, East Asia, South Africa, which means transaction succeeded. But still the user 2 is getting $X. So it is not consistent. So what we have in addition to write, we have another rule here, which is that to get information, the GET request should show data only if it get response from minimum 3 servers. Now see that. Now when user 2 trying to fetch the information, it go to North America server, say $X, it go to South America server, it say $X, then it go to third server, which is any one of them, and for this example, let's say Europe server, which say $X plus Y. So it's a conflicting information coming now. 2 servers are saying we have $X, and the Europe server is saying we have $X plus $Y. So what it does in addition to that, the servers maintain the version of data. I don't want to derail from the CAP theorem here, so I will not go too much into the versioning detail, because that's a separate topic, how the vector clock works to handle entire version of data. So for the understanding here in this video, imagine that each data set has its version. So when ABC account has $X, then it was the version 1. So ABC account $X was version 1.0. When the post transaction executed along with the salary $Y, it go and it say that now balance is $X plus $Y and version is 2.0. So now the user 2, when it's fetching the data, North America is sending the data of version 1.0 $X, South America sending the data $X version 1.0, but Europe is sending the data $X plus $Y and version 2.0. And now system can easily see that the latest version is coming from Europe, so that is the latest data. I should pick that, and now it shows the $X plus $Y. So basically what we did here, we have 2 parameters: number of servers to read and number of servers to write. And if let's say we call them a number m and number n, and if our m plus n is greater than equal to total number of servers. In this example, we pick up there 3 was number of server write and 3 was we pick the number of server read, which was greater than equal to total number of server 5. So it always returning the consistent information. So that's how we achieve the consistency. Now I think we talked enough about the consistency. We know what is consistency, how we can get the eventual consistency, what all parameters we tweak to make it like, strong consistent, weak consistent and all. Now the third thing here is the availability. So what is availability? It's very clear by its name. If a particular or few nodes are is down in the system, still system should serve all the requests from the user. That's called the availability. So system should work even few nodes are down. And in the database we do master and replicas. If master down, a replica take responsibility of this. There are a lot of different things we are doing in the backend to make our system available. And if you will watch my system design videos, you will see like different things we are implementing in different designs to achieve the availability. So that was about the availability. Now we know all three of them. We know what is consistency, we know what is availability, we know what is partition tolerance. So let me come back to the CAP theorem. So I have to draw a diagram which actually clearly tells that what is the CAP theorem is. So this is the CAP theorem. This is C, this is A, this is P. And as I said in the starting of this video, partition tolerance is not optional. So what CAP theorem says, for any design, we have to sacrifice one out of these three options. Means in any system design, either you can have CA or CP or AP. You cannot have all three together, CAP. And as I said, CA is not a realistic case because we need partition tolerance. So I'm not going to talk a lot about it. Let's see how CP works. CP is consistency and partition tolerance, and we are sacrificing on availability. How will that work? So for example, if you want to make a system consistent, that information should be consistent, it means we are looking for strong consistency. So in this case, whenever network outage happening, system becomes unavailable. So we compromising on the availability, but the information is there and we are succeeding any information only when we get success from all the servers. So the post request will come here, and if there is network outage, which is like causing into partition issue or something, and certain part of system is not responding, certain nodes are not responding, we will say the failure, system is not available. So there we compromise the A here. Now if we talk about AP, AP means we want availability, but we are ready to sacrifice consistency. Means here in this case, if few nodes are down, but we want to keep our system up and running, users should get the data, which means that consistency is compromised here now. Servers North America, South America does not have the information of salary $Y because that information is not yet reached to them due to the partition. So we have the availability, system is always up and running, but we compromise the consistency. So that is what the CAP theorem, guys. So guys, please provide your feedback in the comments, and thank you so much guys for joining the session, and I hope it will help you. Thank you so much.